lesson, let us do a few couple of KCSE questions just to find out whether whatever we have discussed so far is understood by you. So our first question is from KCSE 2019. The diagram below shows radiations emitted by a radioactive sample. So we are supposed to identify the radiations labeled M and N. Okay, let's look at this. So we have an electric field with two plates that have opposite charges. One plate has a negative charge, the other has a positive charge. Now, out of the three types of radiations, we know that two are charged. We have positively charged alpha particles, negatively charged beta particles. Gamma rays, of course, have no charge whatsoever. So opposites attract. Alpha particles are going to be attracted towards the negative plate. Beta particles are going to be attracted towards the positive plate. Therefore, M are the alpha particles and N are the beta particles. Part B. Explain what will happen when a sheet of paper is placed in the path of the two radiations. So essentially, the question is simply asking about the penetration power. So when we talk about the penetration power, the gamma rays have the highest one, followed by the beta, and lastly, the alpha rays. Alpha rays are blocked by a sheet of paper. They cannot pass through it. Beta particles can pass through a sheet of paper, but will be stopped by the aluminum foil. So in this case, the beta particles will penetrate the paper and move on, while the alpha particles will be stopped. This is from KCSE 2020. Radioactive decay of thorium-228 gives X, radium, and gamma radiation. So identify particle X. And then write a nuclear equation for the decay. Okay. So we have thorium undergoing radiation to form radium. We are clearly being told that gamma rays are emitted, but I want to remind you this. Gamma rays have no effect on the atomic number or the mass number. And as we can clearly see from this, we are having a change in the atomic and mass numbers. So this is either going to be alpha or beta radiation taking place. Now let us summarize this information by writing a nuclear equation. So there we have thorium giving rise to radium, X, and that represents the gamma particles. Now let's start with the atomic number. We have a decrease in the atomic number by 2. We have a decrease in the mass number by 4. Now, my dear students, whenever you see this atomic number decreasing by 2, mass number decreasing by 4, that is alpha radiation. So we are clearly going to have the release of an alpha particle, which is represented as such. So we've identified X, this is an alpha particle, and we've already written our nuclear equation. Moving on to our third question, this is from 2018. An isotope of lead disintegrates by emitting two beta particles. Determine the mass number and atomic number of the resulting nuclide. Okay, so we have our parent nuclide, which is lead-210, undergoing beta radiation to form our daughter nuclide. Now we want to find out the atomic and mass number of the daughter nuclide. So we have two beta particles being released. When we have a beta particle being released, just a single one, what happens is that the atomic number increases by 1, but the mass number remains the same. Because during beta radiation, you're going to have a neutron converting to form a proton and an electron. The electron is then released while the proton, of course, remains within the nucleus. So in this case, we have a proton being formed. So the atomic number will increase by 1. But we have two sets of beta radiation. So it's going to increase by 2 because of the two beta particles. So our atomic number changes from 82 to 84. What about the effect on the mass number? Now, when it comes to beta particles, the mass number remains the same. Remember, the mass number is the mass of neutrons and protons. So if we have a neutron converting to a proton, what essentially will be happening is that the number of neutrons will decrease, but the number of protons will increase. And if you sum these up at the end of it, you're going to end up having the same value. So the mass number does not change, it remains 210. Now, if you find this a bit confusing, please go and check out my introductory video on radioactivity. It's going to clear this up all for you. Moving on to our next question. This is from 2017. Calculate the values of X and Y in the following nuclear equation. So we have uranium undergoing radioactivity to form thorium. And in the process, 2 alpha particles and 2 beta particles are released. Now, whenever you get such question, just go to the corner of your paper, write this down. Alpha radiation, beta radiation. What happens to the atomic number during the release of an alpha particle? It decreases by 2. What about the mass number? It decreases by 4. Beta radiation, what happens to the atomic number? It increases by 1. There is no effect on the mass number. So in this case, we are having 2 alpha particles being released. So what happens to the atomic number? It's going to decrease by 4, 2 by 2. What about the mass number? It's going to decrease by 8, 4 multiplied by 2. Remember, we are having 2 alpha particles released. Let's move on to the beta particle. With the beta particle, you're going to have the atomic number increasing by 2. For each beta particle, the atomic number increases by 1. And since we have 2, the atomic number increases by 2. There's no change in the mass number. Okay, we are now ready to just sum this up. So let's start. Our initial atomic number is 92. Due to the alpha particles, it's going to decrease by 4, giving us 88. But because of the beta particles, it's then going to increase by 2, giving us a final value of 90. So Y represents 90. Moving on to the mass number. The mass number is going to decrease by 8 because of the 2 alpha particles. So the mass number is now going to change from 239 to 231. What about the beta particles? They have no effect on the mass number. So our final value of X is 231. Moving on to our last question, complete the nuclear reaction below. So we have Q undergoing radioactivity to form P. Now, let's look at the atomic number. The atomic number is decreasing from 88 to 86. So essentially, it's decreasing by 2. What about the mass number? It's decreasing by 4. Ladies and gentlemen, you see this, and this type of particle is the alpha particle, which is represented as such. And that, my dear students, brings us to the end of this lesson. I hope by now, whether you have been taught or not in your respective schools, I hope that radioactivity imelala and in a good way. See you next time.